I'm live again. It's Mechatronics. I'm still gonna troubleshoot this machine here. It's CNC TNS2A. As you all know that CNC is a computer numerical control machine. It uses binary information to do whatsoever that it does. So right now, I was just troubleshooting the system, checking what's wrong with it. Actually, I'm doing mechatronics. You all know that I'm doing mechatronics, right? And mechatronics, it is a combination of multidisciplinary engineering fields. Basically consists of mechanical engineering, electrical engineering, information technology, and electronics. I don't know if you can be able to see it. Electronics. So we are using these combined skills to troubleshoot industrial equipment and to fix industrial equipment as well. So I started mechatronics at Sidiben College in Sibuken campus, and I went far to complete it at Ekurhuleni West TVET College. So this career is very nice. I like it very much because of it keeps me busy. It makes me to think. It makes me to think out of this world or out of the box, out of this skull. So I like mechatronics very much. So go with me. Explore the world with me as well. This one is CNC TNS2A. It uses a Fanuc control, as you can see. So I was still busy with it. There are only 2 errors on the machine right now. So I'm gonna put some diodes on it. These are the diodes that I'm gonna use there. No, sorry, not diodes, resistors. These are the resistors that I'm gonna use. I'm gonna troubleshoot and replace them at the back there. It uses a 3-phase as well. I want to adjust my fins here. I just want to adjust my fins here so that you can be able to see me clearly. I need a very high supervisory control and data acquisition. I think I will need that kind of system because right here I'm going to talk about mechatronics, and mechatronics is a very nice career. I like it very much because of it teaches me a lot of things. Actually, I'm still alive, but I don't know why it keeps on buffering on the other side. But here on the master system, it does not buffer. So the only thing that I want to get right now is the mechatronics. These are mechatronics. Let me just see PDF. Yes, PDF. I'm just gonna explain what is a mechatronics, because mechatronics is a very nice field. You can see even the machine at the back of me there. It uses a mechatronics as well. So this career is very nice. Can achieve a lot of things with it. Can automate a lot of stuff. You can troubleshoot. You can maintain. You can install. Can do a lot of things actually. Let me just see. Uh, okay, it is written that Mechatronics, the name Mechatronics was coined by Kikuchi, now president of Sakawa Electric Company, Chiyoda Ku, Tokyo. Arkame Fort, Mecha what? Okay, that's a reference. The word mechatronics is composed of mecha from mechanics and tronics from electronics. In other words, technologies and developed products will be incorporating electronics more and more into mechanisms intimately and organically, and making it impossible to tell where one ends and the other begins. Uh, I'm going to talk about the mechanics, mecha, and electronics as well. What I'm talking about. Ish, I'm sorry for that interruption. I think I'll have to start this from scratch again to explain what mechatronics is all about. I like this field very much, but actually, I'm still busy with mechatronics stuff or related stuff. Even if you see me based with someone else or someone who's requesting something from me right now, you must know that it is mechatronics related and there's nothing wrong about it. As you can see at the back of me there, I do have a CNC T and S2A. And as it is written on this laptop, the word mechatronics is composed of mecha, from mechanics, and tronics from electronics. In other words, technologies and developed products will be incorporating electronics more and more into mechanisms, intimately and organically, and making it impossible to tell where one ends and the other begins. As we have said, mechatronics includes mechanicals and electronics, and there is a information technology involved in it, and there is a mechanical stuff involved in it as well, or electronics as well. Let me just see another. Let me just see another integration of electronics, control engineering, and mechanical engineering. Application of complex decision making to the operation of physical systems. Synergistic integration of mechanical engineering with electronics and intelligent computer control in the design and manufacturing of industrial products and processes. Mechatronics, what is it and why and how? Mechatronics defined. Point number one, it is synergistic use of precision engineering control theory, computer science, and sensor and actuator technology to design improved products and processes. Methodologies used for optimal design of electromechanical products, as I've said in the previous minutes or in the previous videos. The other explanation is that it is a field of study involving the analysis, design, synthesis, and selection of systems that combine electronics and mechanical components with modern controls and microprocessors. There is a working definition for us to explain mechatronics. Simply, we explain it in this way. Mechatronics is the synergistic integration of sensors, actuators, signal conditioning, power electronics, decision and control algorithms, and computer hardware and software to manage complexity, uncertainty, and communication in engineered systems. This machine is a very nice example of what I'm talking about here. Yes. Engineered products frequently involve components from more than one discipline. Traditional product realization, point number one can be discipline-specific sequential process, design, then manufacture. We're going to use this machine to do that. Bottleneck, suboptimal integration. We are using PLCs. We are using Fanuc simulators. We are using complex electronics to troubleshoot this system as well and to design it as well. Mechatronics-based product realization exploits. Integrated process founded upon interdisciplinary synergy. Disciplinary foundations of mechatronics. Point number one, it is mechanical engineering. Point number two, as I've said, it is electrical engineering. Point number three, it is computer engineering. Point number three, it is computer and information systems. All those what can I say? Sorry for that. Products and processes requiring inputs from more than one discipline can be realized through following types of interactions. Multidisciplinary means this is an additive process of bringing multiple disciplines together to bear on a problem. Point number two, cross-disciplinary. In this process, one discipline is examined from the perspective of another discipline. Interdisciplinary, this is an integrative process involving two or more concurrent product realization. And this one, it says that sequential and discipline-specific concurrent design processes for product realizations are at best multidisciplinary, calling upon discipline specialists to design by discipline. Design mechanical system plant. Select sensors and actuators and mount on plant. Design signal conditioning and power electronics. design and implement control algorithm using electronics, microprocessor, microcontroller, or microcomputer-based hardware. Mechatronics-based product realization. Point number one can be systems engineering allows design, analysis, and synthesis of products and processes involving components from multiple disciplines or multiple engineering fields. Mechatronics exploits systems engineering to guide the product realization process from design, model, simulate, analyze, refine, prototype, validate, and deployment cycle. That is part of quality assurance. In mechatronics-based product realization, mechanical, electrical, and computer engineering and information systems are integrated throughout the mechatronic system is not simply a multidisciplinary system, simply an electromechanical system, just a control system. It is complex than that. We have information for future modules and upgrades as well. And we are learning from our mistakes as well. Mechatronics is not a field to say it is perfect. No, it's not perfect. We are just using our capabilities to explore what these machines have for us. These machines are just big. They have nothing big, actually. They just, or can I say, they are just big in structure. There's nothing more complex about them, or there's nothing scary about them. Evolution of mechatronics as a contemporary design paradigm. Technological advances in design, manufacturing, and operation of engineered products, devices, processes can be traced through number one, industrial revolution. Number two, semiconductor revolution. Industrial revolution it is the kind of technology that is used in the industrial sectors to minimize costs so that companies can get profit, things like that. And number two can be semiconductor revolution, the way these resistors have been built up, the way these capacitors have been built up, the way these diodes have been built up time to time. And another one, it is information revolution. That information we can get it from internet. That information we can get it from the textbooks. That information we can get it from library. That information we can get it from someone who has experimented something, then concluded by his hypothesis. So that there is a industrial revolution, there is a semiconductor revolution, there is a information revolution as well. And those evolution of mechatronics as a contemporary design paradigm, they form technological advances in design, manufacturing, and operation of engineered products, devices, processes can be traced through those revolutions. Another one, we are just explaining the industrial revolution here. Point number one is that allow the design of products and processes for energy conversion and transmission, thus allowing the use of energy to do useful work. You know that energy cannot be created or destroyed, but can be transformed into another kind of energy. Let's not get deep into that. Point number two is that engineering designs of this era were largely mechanical. Example can be this capacitor. Previous industrial revolution, these things were bigger in size. Now they are just smaller, like this. They have been reduced in size as well. They have been reduced in size. You can see here we have smaller capacitors here. We have smaller capacitors in that plastic. You can see that. And here we have a bigger one. So engineering designs of this era were largely mechanical, e.g. operations of motion transmission, sensing, actuation, and computation were performed using mechanical components such as cams, gears, levers, and linkages. A purely mechanical system, point number three can be purely mechanical systems suffer from power amplification inability, or maybe what can you call it, signal conditioning status. Energy losses, there is energy losses due to tolerances. Here we are using approximately plus or 10 tolerances, inertia and frictions on mechanical, electronics, information technology, and stuff like that as well. semiconductor revolution. Number one can be led to the creation of integrated circuit or IC. I do have it here. Let me just check it. I think I do have it here. A good example of IC or integrated circuit can be, let me just look for this one as well. Let me just look for this one. Can see here. I don't know if you can be able to see it clearly. They say that it led to the creation of integrated circuit. These single components, they were combined into useful integrated circuits. Integrated circuit is a smaller chip like this one. I don't know if you can be able to see it. Yes, the smaller chip like that one. It led to a creation of integrated circuit to reduce the space, mechanical properties of components and stuff like that. You see that those ICs have been used into this circuit here, those integrated circuits. Just imagine if we had to disassemble those integrated circuits and take out the components that have been combined inside of it there. And point number two can be effective miniaturized power electronics could amplify and deliver needed amount of power to actuators. Point number two can be signal conditioning electronics could filter and encode necessary data in analog or digital format. Point number three or number four can be that hardwired onboard discrete analog and digital ICs provided rudimentary computational and decision-making circuits for control of mechanical devices. An integrated circuit can be an example. An A2D converter, analog to digital converter, an operational amplifier or OPM can be another example as well. Another revolution, it is information revolution. Point number one, it is development of VLSI technology led to the introduction of microprocessor. Microprocessors they play a very nice or very useful role in mechatronics and microcomputer and microcontrollers as well. They do play a very useful part in mechatronics as well because of those small parts. They very sorry for that bad English. I like this field very much. As you can see here, here is a microprocessor. They have been used. There's a microcontrollers there as well. There's a microcontrollers there as well. Those development of VLSI technology led to the introduction of microprocessors, those ones that I have talked about, and the microcontrollers as well, and microcomputers as well. The microcontroller, as I've told you, it is this small component. Microprocessor is the one that has a CPU, and it is the brain of the computer as well. It is used for gaming, web browsing, and stuff like that. The example can be a computer, but microcontroller, it is designed specifically for it is designed specifically for a certain task. I can say that, but computer can do multiple tasks, but microcontroller is designed for a specific task. That's the difference between those things. Point number two can be that now computing hardware is ubiquitous, cheap, and small. That's true, because if you had to deassemble those microcontrollers, we'll spend buying those components to do those microcontrollers. Those microprocessors and microcontrollers, they do play a very useful role in industrial center or industrial, Point number three can be that as computing hardware can be effortlessly interfaced with real-world electromechanical systems, it is now routinely embedded in engineered products, processes for decision-making. Microcontrollers are replacing precision mechanical components, e.g. precision machined camshaft that in many applications functions as a timing device. Now we are having microcontrollers performing those tasks, but those tasks were performed by what we call a camshaft in the previous industrial revolution. Programmability of microcontrollers is providing a versatile and flexible alternative to the hardwired analog and digital computational hardware because of those things were they have to be connected first in the order that have to create a what do you call logic. There's a AND gate, there is a OR gate, there is a NOT gate as well. Let me not get deeper into those things. Another one can be integrated computer electrical mechanical devices are now capable of converting, transmitting, and processing both the physical energy and the virtual energy information. Hey, this is amazing. This is amazing. Integrated computer electrical mechanical devices are now capable of converting, transmitting, and processing both the physical energy and the virtual energy into an information required by these microprocessors so that it can be able to output that information, creating something useful. Point number 4 or 5 can be that result. Highly efficient products and processes are now being developed by judicious selection and integration of sensors, actuators, signal conditioning, power electronics, decision and control algorithms, and computer hardware and software. Let me talk about elements of mechatronics. Basically, we're going to talk about mechanical structures as well. Mechanical elements refer to mechanical structure, how big this machine look, mechanisms, those tool turrets, thermal fluid, the hydraulic pump used to turn the coolant on this machine. Let me turn off. It seems like I have turned the conveyor on. Let me just turn it off here. Ish. Sorry, saying was focusing. Sorry, saying was focusing on mechanical elements, and I've said that mechanical elements refer to mechanical structure, mechanism, thermal fluid, and hydraulic aspects of a mechatronic system, because of those hydraulic or hydraulic technologies, the use of compressed fluid to do a useful task in a mechatronic system. Point number 2 can be mechanical elements may include static, dynamic characteristics. And point number 3 can be that a mechanical element interacts with its environment purposefully. And point number 4 can be that mechanical elements require physical use most heat grinding machine, and it has a chain, or can I say gear, sorry. Elements of mechatronics, especially on electromechanical side. Electromechanical elements refer to sensors is a variety of physical variables. Sorry. A variety of physical variables can be measured using sensors, e.g., light using photoresistor. This light that you see here, we can measure it using light. We can measure light using a photoresistor. Level and displacement using potentiometer. Direction, tilt using magnetic sensor. Sound using microphone, just like this one that I'm using right here. Stress and pressure using strain gauge. Touch using micro switch. Temperature and humidity using conductive sensor or conductivity sensor. And we also have actuators, and on actuators we do have a DC servo motor, Servo motor, it is the one that provides a feedback or that has a feedback on it. We also have a stepper motor. We have a relay. We have a solenoid. We have a speaker. We have a light emitting diode or LED. We have a shape memory alloy. We have electromagnet and pump apply a commanded action on the physical process. Another one is AC-based sensors and actuators, digital compass, potentiometer, etc. We have a FlexiForce sensor. We have a ultrasonic ranger. We have a DC motor. We have a pneumatic cylinder. Elements of mechatronics, especially, and sorry, it seems like my video has been interrupted. Seems like my video has been interrupted. Seems like my video has been interrupted, but I'll still continue. There is an electrical element referred to electrical components such as resistor, capacitor, inductor, transformer, etc. Circuits and analog signals. Point number 2 can be electronic elements referred to analog, digital electronics, transistors, thyristors, opto-isolators, operational amplifiers or OPMs, power electronics, and signal conditioning. Point number 3 can be the electrical or electronic elements are used to interface electromechanical sensors and actuators to the control interface, computing hardware elements as well. Elements of mechatronics, especially on control interface and computing hardware. Point number 1 can be control interface or computing hardware elements referred to analog to digital A to D converter, digital to analog converter, digital input and output, counters, timers, microprocessor, microcontroller, data acquisition and control or SCADA system, DAC board, and digital signal processing, DSP board. Point number 2 can be control interface hardware allows analog and digital interfacing. Communication of sensor a signal to the control computer and communication of control signal from the control computer to the actuator. Point number 3 can be control computing, hence a control algorithm, measurements to compute control actions to be applied by the actuator. Elements of mechatronics, especially on computer and information system. Computer elements refer to hardware and the software utilized to perform. Point number 1, computer-aided dynamic system analysis, optimization, design, and simulation. Point number 2, visual instrumentation. Point number 3, rapid control prototyping. Point number 4, hardware in the loop simulation. Point number 5, PC-based data acquisition and control or SCADA system. Elements of mechatronics. Point number 1, a typical knowledge base for optimal design and operation of mechatronic systems comprises of, point number 1, dynamic system modeling and analysis, thermo, fluid, structural, hydraulic, electrical, chemical, biological, etc. Point number 2, decision and control theory. Point number 3, sensors and signal conditioning, actuators and power electronics. Point number 5, data acquisition, analog to digital, digital to analog, digital input output, counters, timers, etc. Point number 6, hardware interfacing. Point number 7, rapid control prototyping. Point number 8, embedded computing, balance theory, simulation, hardware, and software. We also have key elements of mechatronics, and those key elements of mechatronics on the first system block diagram, it is mechatronics is equals to simulation and modeling, automatic control, optimization, real-time interfacing as well, electrical systems, digital to analog and analog to digital. And we also have computer systems, which is this one that we are using to stream as well. And we also have mechatronics applications. Number 1, smart consumer products like home security, camera, microwave oven, toaster, dishwasher, laundry washer dryer, climate control units, etc. Point number 2, medical, it can be implant devices, assisted surgery, haptic, etc. And on defense, we can use this for unmanned air, ground and underwater vehicles, smart munitions, and jet engines, etc. On manufacturing, we can use it for robotics, machines, processes, etc. On automotive, we can use it for climate control, anti-lock brake, active suspension, cruise control, airbags, engine management, safety, etc. On network centric, we can use it for distributed systems, distributed robotics, telerobotics, intelligent highways, etc. On home automation, using a computer, turn on the lights at preset times, adjust the brightness, turn on the heat at preset times or temperatures, serve as a security system, can do that as well. On robotics, can also use that to palletize, sort, uh, weld, arc weld, TIG, MIG, and of course storage and remote arm and monitoring, quality assurance, things like that as well. Uh, Thank you very much. This was a really live uh, introduction of mechatronics according to how I understand it, according to what I have just read, and putting it into reality as well. So mechatronics is a very nice field to get yourself into. You can study it at college, you can study it at university, as long as you are getting the skills that you are supposed to get. Then of course you'll get that skills that is required. To, of course, troubleshoot industrial equipment and being competitive into industrial equipment as well. So I'm live right now. Even Mr. Jacob can become live. You can see. Even Mr. Jacob as well, he can become live as well. He was also assisting me with some of the stuff here. So we are still troubleshooting. We are still learning a lot of things. But as well, as I've said, mechatronics is a very nice field. So we are given time by Paro to troubleshoot and do other stuff like that as well. So Mr. Jacob is the one who's giving us access to the workshop as well to troubleshoot these machines that you see at the back there. So he's the one who also give us the keys and stuff like that. So mechatronics is a very nice field to, of course, invest into. So we are live right now. As you can see that we have been live for more than 40 minutes. I think after 50 minutes, I'm gonna switch it off because I was just explaining the mechatronics to these people here. So I think you'll be a witness as well to tell them that mechatronics is a very nice field. I'm learning a lot of things here.
Doing nice things.
Yes, yes.
I'm always watching him when he's doing mechatronics.
Yes.
I can say too, he's very intelligent guy. Okay, thank you.
Thanks, Mr. J. Thanks. Yabonga, Baba. Thank you, Baba. Thank you. Yeah, that one is Mr. Jacobs from Leparo. He's the one who provides with keys and stuff like that. So I was just explaining mechatronics in detail. What is it all about? We are doing robotics and other complex stuff like that. So you can also study mechatronics. You can just look commercial or maybe local community college that does that does offer mechatronics. So you can study the skills, have the qualification, and be able to explore the world as well. So mechatronics is a very nice field. Don't be scared to invest in it or maybe hire someone who has a qualification in it because of it's a high level knowledge based qualification that will allow any person actually with mechatronics, can I say, you can be able by hiring just one person who has a mechatronics qualification, we have just hired four people at once. We have hired mechanical engineer, we have hired information technology engineer, we have hired a electrical engineer, we have hired electronics engineer, and we have hired a very intelligent someone, as Mr. Jacob said, just said. So it's not about color, it's not about, it's all about the skills. What do you know? What can you do? My English is not that good, but I can even present this in foreign languages as well if I can be able to learn them. You see, English is not my home language. It's not my mother language. I'm a Sotho speaking. My father is a Zulu speaking person, but let me not get into that. I'm an engineer, and I like that. I enjoy what I'm doing, and I'll forever enjoy what I'm doing. So I'm competitive, and you can hire me if you want to. You can hire us later. Later, we're solving for X. Yes, we're solving for X. And thank you very much. Thank you very much. I'll be back again on another video. I'll see what I will talk about. There's a lot of things to talk about in this field as well. There's a lot of things to learn as well. So I'll see what I'll come back with when I come back. Thank you very much. This one, it was recorded on the 20th of June 2018. I have freestyled it. I was using the reference from my own laptop. I was using PDF books from the college as well to present it. So if I did mistake anywhere, you can put them into the comment below and tell me where should I improve. Accept feedback, of course. Thank you very much.